How high can sine x plus cosine x go? Watch two perpendicular unit arms. Slide the red arm until its tail meets the cyan tip. Its sined vertical component stays unchanged. The locked unit arms become adjacent sides of a square. Its diagonal has length the square root of 2. At 45 degrees, the diagonal points straight up, so its height reaches its maximum, the square root of 2. Keep x turning. Why does this height trace a single sine wave shifted 45 degrees to the left? Start with cyan. At angle x, its endpoint is cosine x across and sine x up. Its sined vertical component is exactly sine x. The red arm stays 90 degrees ahead. Its endpoint is minus sine x across and cosine x up, so its sined vertical component is cosine x. Once the red arm's tail is placed at the cyan tip, its sined component begins where the cyan component ends. Together they make the yellow diagonal's sined vertical coordinate. The square has told us two things. The diagonal has length the square root of 2, and it points 45 degrees ahead of the cyan arm, modulo a full turn. The diagonal has length the square root of 2 and points at x plus 45 degrees. Its sined vertical coordinate is the square root of 2 times the sine of the quantity x plus 45 degrees, our sum. Keep x turning. The diagonal's endpoint passes a moving slit and prints one yellow wave, taller than sine and shifted left by 45 degrees. At 135 degrees, cyan points up and red points down equally. Their sined components cancel, so the yellow trace crosses 0. Now give the cyan and red arms positive lengths a and b. The square stretches into a rectangle, but the tip-to-tail logic stays unchanged. The diagonal has length r, the square root of a squared plus b squared. Phi is the acute angle from the cyan arm to the diagonal. Then cosine phi is a over r, and sine phi is b over r. The diagonal points at x plus y, so its sined vertical coordinate is r times the sine of that angle. The colored components give the same coordinate, a times sine x plus b times cosine x. The addition formula confirms the geometry. The cyan side gives r times cosine phi equals a. The red side gives r times sine phi equals b. As the positive length b shrinks toward 0, the red side vanishes in the limit. Then r approaches a, phi approaches 0, and the formula tends smoothly to a times sine x. Two waves, one diagonal. Its length sets the amplitude. Its direction sets the phase. Subscribe for more math made visible.